In this video, we are going to cover nomenclature of substituted benzenes. Monosubstituted benzenes are named using benzene as a root and naming the substituent and listing that in front of benzene root. So, for example, chlorobenzene, bromobenzene, nitrobenzene, ethylbenzene. Simply naming the substituent and then following that by root or benzene. Alkyl substituents are named as alkyl substituents, such as you have already seen ethylbenzene, so propylbenzene, isopropylbenzene. Some of them also have trivial name or names that are in common use. For isopropylbenzene, that's cumene. Then here is tertiary butylbenzene and secondary butylbenzene. So obviously, for naming of monosubstituted benzenes, one has to know naming of alkyl substituents, and one has to be really good at it. Some of the monosubstituted benzenes have trivial names listed here that are in common use, and in fact even some of those trivial names are in such common use that they have been adopted as systematic names. You should memorize at least trivial names of the compounds, of the 7 compounds listed here. You may want to pause the video here and look at this list in detail. So from left to right, that's toluene. So we never call this methylbenzene, we always call it toluene. Then next, some of these we have already seen before, like phenol, aniline, anisole, styrene, benzoic acid, and benzene sulfonic acid. Obviously there are more, but these are the most important ones. As a substituent, benzene ring is named phenyl. Make sure that you do not mix up phenyl with phenol. Phenol is just above. Phenol is actual compound, phenyl alcohol, so phenol for short, while phenyl is benzene ring as a substituent. In general, if there is, for example, substitute benzene ring, something that has other atoms on it, and we don't want to specify what it is, we will simply call it aryl. So in general, such substituent is called an aryl substituent. And again, for emphasis, phenol is listed here so that you don't mix up phenyl with phenol. Then we have benzyl substituent, which is also very important not to mix up with phenyl, because name benzyl is very similar to benzene. So, but benzyl refers to a specific substituent, and that's C7H7. So benzene ring attached to CH2 group. So again, very different from phenyl. And we use benzyl in nomenclature a lot. For example, to name compounds such as benzyl alcohol or benzyl bromide. And here is an example. You may want to memorize this one. This one should help you in memorizing which substituent is benzyl and which one is phenyl, since both are incorporated in the same compound. So this is benzyl phenyl ether. Disubstituted benzenes are named by listing substituents in alphabetic order and indicating positions of substituents. We can indicate positions by using numbers, such as 1, 2, 1, 3, or 1, 4. Those are 3 possibilities for a disubstituted benzene. But much more common is older nomenclature that originates from 19th century, and that's ortho, meta, para nomenclature. That nomenclature is used exclusively for disubstituted benzenes and nothing else. It's not used for tri or polysubstituted benzenes, only for disubstituted benzenes. So 1,2 disubstituted benzene is an ortho isomer. In this case, we have 2 identical substituents, so this would be 1,2 dichlorobenzene, or more commonly ortho dichlorobenzene. Next compound is dibromobenzene, so 1,3 dibromobenzene, or again more commonly meta dibromobenzene. And finally, we have example of para substitution, so 1,4 diiodobenzene or para diiodobenzene. So ortho, meta, para is much more commonly used. With different substituents, we list substituents in alphabetic order. So this would be meta nitropropylbenzene, and that's how we would commonly name it. We can also name it 1-nitro-3-propylbenzene. That would not be wrong. If substitute benzene has one of those substituents that gives new name to the entire compound, such as toluene or anisole or phenol or aniline, or as in this case benzoic acid, then we name disubstituted benzene as such substitute compound, as substituted derivative of that compound. So in this case, we have chlorobenzoic acid, and we would name it as metachlorobenzoic acid. This name is used almost exclusively. Trichlorobenzoic acid is not wrong, but would be very rare. Typically, we name these as orthometa paraderivatives, so it should be named as metachlorobenzoic acid. Here is another example. We have methyl group on benzene ring. It means that that's toluene, and substituent is cyclopropyl. So this is cyclopropyl toluene. We can also name it 1-cyclopropyl 2-methylbenzene. This is actually a computer-generated name. Probably not wrong, but I have never seen something like that used. So orthocyclopropyl toluene is appropriate name for this compound. And this is an aniline, so this would be orthobromoaniline. Again, we can name it 2-bromo-benzamine. That's again a computer-generated name. So orthobromoaniline is really correct name for this compound. Then there are some disubstituted benzenes that have names of their own. And again, you may want to memorize these, particularly xylenes. So dimethylbenzene is actually not named dimethylbenzene. It's also not named methyltoluene. One could come up with that. It has its own name. It's xylene. And of course, methyl groups could be in different positions on benzene ring. So we have 3 different xylenes. So there is ortho, meta, and paraxylene. So 3 isomeric xylenes. And then sometimes we have 2 substituents on benzene ring where each individual substituent would give a name to that compound. For example, hydroxyl group on benzene ring gives name to that compound as phenol. Methyl group gives it as toluene. So what if both are present? Well, then we give entirely new name to such disubstituted benzene. In this particular case, that would be cresol. So this is just an example. Of course, you can't memorize every such single example of those cases. So this is just for you to get some idea how we name such compounds. So if there is both hydroxyl and methyl group present on benzene ring, we name that compound cresol. Again, no way to reason that out. You have to memorize that. So if they are in 1,2 position relative to each other, that's orthocresol. 1,3, that's metacresol. 1,4, paracresol. Tri- and polysubstituted benzenes are named by extension of rules we have learned so far. Here is one example. We have tri-substituted benzene, and substitution pattern like this could be only 1, 2, 4. Keep in mind that 1, 3, 4 is not possible, because if you name something 1, 3, 4, that means you have made a mistake. Simply because we have to assign smallest possible set of numbers to substituents. And then substituents are listed in alphabetic order, not in the order of increasing numbers. It has to be alphabetic order. So chloro substituent comes first, then fluoro, then nitro. And then whatever numbers they are assigned to have smallest possible set of numbers. So this would be 4 chloro, 1 fluoro, 2 nitro benzene. And here is another example. If, of course, we have identical substituents, then we use prefixes di and tri as needed. So again, 1, 2, 4 substitution pattern. So this would be 2 bromo, 1, 4 dinitro benzene. Now, when substitution pattern is 1, 3, 5, then substituents are always listed in the order of increasing numbers. Because when there is a tie, then alphabetically first substituent is listed first. And with 1, 3, 5 substitution pattern, of course, in a ring we can start at any substituent being substituent 1, and we can list them clockwise or counterclockwise. So 1, 3, 5 will always be listed in the order of increasing numbers. So it's going to end, of course, alphabetically first, then second and third. So it's going to be, in this particular case, 1 chloro, 3 ethyl, 5 nitrobenzene. So alphabetically, chloro comes first, then ethyl second, nitro third, and that's how we'll assign them numbers to break the tie. Now, if benzene has one of those substituents that gives entirely new name to the compound, then tri and polysubstituted benzenes are named as derivatives of those compounds. So first example would be phenol, then carbon that carries OH group, OH substituent is carbon 1. We don't list that number 1, we simply assume that carbon is 1, and then we list remaining substituents and give them numbers, smallest possible set of numbers, keeping in mind that we already have carbon 1. So this would be 2,4-dinitrophenol as first example. Then next would be 2,4,6-trinitrophenol or picric acid. And keep in mind that now, since number 1 is fixed and other substituents have to be numbered relative to carbon 1 that carries substituent that gives name to the entire molecule, then 1,3,4 substitution pattern is possible. So now 1,3,4 substitution pattern is possible, and this is this third example. 4-bromo 3-chloroaniline. And again, note that in none of these three examples we listed number 1. It would have been wrong to include number 1 as part of the name. And here are some more examples of polysubstituted benzenes. So when we have more than 3 substituents, simple extension of what we have learned so far. So we have phenol and 4 chlorine substituents. So this is 2,3,4,6 tetrachlorophenol. In the next case, we have 4 substituents and we'll have to list all 4. So again, smallest possible set of numbers, and list substituents in alphabetic order. So it's going to be 2,5-dibromo 1-chloro-3-ethylbenzene. Finally, in the last example, we have hydroxyl group, which would name this substituent as phenol, and then carboxyl group as benzoic acid. Benzoic acid has priority. This is only listed as an example. There is no way to reason this out. You would have to be told this. So this is just listed an example. How would you name some rather complex compound? So in this case, actually, hydroxy substituent is named as hydroxy because compound is named as benzoic acid. So this would be 3-chloro-2-hydroxy 6-nitrobenzoic acid. This completes review of nomenclature of substituted benzenes. Next, we are going to examine reactions of benzene.